Hello, fifth graders. Hope everyone's doing well. It's Mr. Bentley. We're going to take just a few minutes this morning to go over fractions. We're going to look at the bar model, which is a way for us to model fractions as the parts relate to the whole. And then we can use those models to represent and solve different problems that definitely connect back to real life, which is really cool. So our problem today is about Alex, who works a part-time job. It says, last week he spent 2/5 of his weekly paycheck on bills, 1/3 of the remaining on gas. The rest of his weekly paycheck was spent on coffee and fast food. The $8 he spent on coffee was 1/5 the amount he spent on fast food. How much money did Alex get in his weekly paycheck? So I'm going to turn the camera just a little bit and solve. So I jotted down a few of the important details from that problem. First, that we have 2/5 spent on bills, 1/3 of the remaining on gas, the remaining, which would be 2/5 on fast food, and then $8 on coffee is 1/5 the total that he spent on coffee and food. So looking at the bar model, what we use is, well, a bar. So we start by drawing a bar that represents the whole. So in this case, our whole is all of Alex's paycheck. And then based off the problem, we know that 2/5 of that was spent on bills. So if I divide my whole into 5 parts, as so, then 2/5 would be spent on bills. Just like that. And then it goes on and says 1/3 of the remaining is spent on gas. We'll have 3 parts remaining, so 1/3 of that would be one of these whole parts. And that is spent on gas. It says that the rest of his paycheck goes to food and coffee. So I'm going to go ahead and label that real quick. That way we know what these final 2 parts represent. And that makes up his whole paycheck. We see that modeled here with the full paycheck, and we see that modeled with that second bar. It goes on and says that the food and coffee of that 1/5 was spent on coffee specifically. So I can rewrite this part, dividing it into fifths to model what we have going on here. Alright, so you can see right here, I just dropped this bar right here with the bills, gas, food, and coffee right here on the bottom, and you can see that it still stayed the same. But then on this middle one here, what I did is I repartitioned this 2/5 of the whole and found a way to divide it into fifths to represent this whole as the food and coffee, and then each part as just the amount he spent on coffee. And it said that 1/5 was spent on coffee. It also said that this equals $8. So here I have $8, and since all of these right here, right here on those between those 2 dashed lines, each of those parts is equivalent to $8. So I have 5 parts, each with $8 in them. So I know in between in this part alone, I have $40 total. And that $40 accounts for the food and coffee alone. So looking back at that first way that we divided it, we had the bills, we had the gas, and then we had food and coffee. Well, we know that this food and coffee total now accounts for $40. And that $40 is 2 parts of my whole paycheck, which we see up top. Well, if I want to divide my $40 into 2 parts, I know that $20 would go into each part. So if I have $20 in each of those 2 parts, and I have 5 equal parts, then I have 5 parts each with $20, which would be, I could either write as $20 plus $20 plus $20 plus $20 plus $20, or I could say $20 found in each of the 5 parts, so times 5 parts equals $100 to show my parts to whole. So out of the whole paycheck, $100 was in his paycheck. And then we see $20 in each of those parts. So we'd be spending $40 on bills, $20 on gas, and another $40 on food and coffee. I can also show this abstractly as well. So I would say that 2/5 is spent on bills, as we see here, and then 1/3 of the remaining is spent on gas. So I would say 1/3 times, and then my remaining parts would be 3/5, and that gives me 3/15. I can use the identity property and divide by 1 or divide by 3/3. So 3 divided by 3 gives me 1, and 15 divided by 3 gives me 5. So my 3/15 equivalent fraction is 1/5. And that accounts for the amount Alex spent on gas. From there, it says that 1/5 of the remaining was spent on coffee, which equals $8. So I have 3/5 total, so that means I have 2/5 left in this paycheck, and 1/5 was specifically coffee. This 2/5 is his food and coffee, and the 1/5 will show us exactly how much he spent on that coffee. So if I multiply across, I get 2 over 25. So that means for the 25 parts that he spent, 2 of those, 2 parts for every 25 would be spent on coffee altogether out of his total paycheck. Another way I could write this would be if I use the identity property again and multiply by 2 over 2, which just equals 1. And I would get 4 out of 100. So for every 4 parts to every 4 out of 50. So for every 4 parts it's spent on coffee to the 50 parts that is the whole. Another way I could write this would be to multiply it by 2 over 2 again, which would give me that 100 that I wrote earlier. Of 8 parts for every 100 was spent on coffee. Well, I know that $8 was spent on coffee specifically. So for every 8 parts, I spend $8. So for each part I have, I'm spending $1. So if I have 100 total parts in his paycheck, looking at that 8 parts to $8, then I know that 100 parts would equal $100 total for his paycheck. So I hope that makes sense, guys. If you have any questions, please let me know. I really enjoyed the bar model and then looking at it abstractly. So if you guys have questions, again, just please let me know. Otherwise, you guys enjoy your Sunday, and thanks so much. Bye.